All right, 2.4, the chain rule. So what the chain rule does is the chain rule tells us what happens when we have a function embedded inside of another function. So imagine a very straightforward one that you've seen before is when you have something besides just x underneath the square root. So there's a square root, and then underneath the square root, there's several other things going on, right? So you've got one function inside of something else. So what this tells us that you can do when you have a function inside of another function is that you take the derivative of the function that's handling itself on the outside, and you rewrite the inside piece inside of it, and you multiply that by the derivative of the inside piece. So you heard me saying these words, so I'm going to write them down. It's the derivative of the outside times the derivative of the inside. So every time we look at these, I'm going to focus on that language of what is on the outside, what is the outside function, what is on the inside, what is the inside function when we're looking at the pieces. And we're starting with one that we could actually do with a little bit of algebra simplification if we really, not a little bit, a lot, but we could do it with algebra simplification if we really wanted to. This is the power of 5. I could, if I really wanted to, multiply this thing out 5 times. I could. I don't want to. But I could, right? So it's much easier to do this with the chain rule because I don't want to multiply this out 5 times. That sounds miserable. So here's the deal. I'm going to highlight the inside. Does everybody agree that looks like it's inside of something? And in particular, the inside often occurs inside of a set of parentheses or parentheses that your calculator would sort of put in there for you if you didn't have them on there already. So these are this one is the inside function because it's inside of these parentheses. And then the outside part is the fact that you have the power of 5. The 2 at the beginning is kind of inconsequential. It's a constant multiplier, just like when we have 2s before. It's going to come along for the ride. It's not going to affect anything. But the power of 5 at the end will. So when you have a power of 5, the power rule says I take the power of 5 and I multiply it by the function that I'm dealing with, right? I bring it down as a coefficient. So my derivative here, the outside's derivative, will involve having a 10 here, the 5 that was the exponent times the 2 that was in front, and making it a power of 4. That's the derivative of the outside. And then the part that was already written here simply gets rewritten. Okay? And then the part now that's in orange, the inside derivative is what I do the piece next. I multiply. So what is the derivative of 6 minus x squared? Negative 2x. That's the derivative of the inside. Very little cleanup on this one. The only thing I really need to do is to combine the negative 10 at the beginning the 10 at the beginning with the negative 2x at the end. So this would be negative 20x squared times 6 minus x squared. I'm sorry, not x squared, just x. 6 minus x squared to the 4th. So that is just a taste of the chain rule, and we will finish that lesson next time.